Hello. So today we're going to talk about control and performance. So we're going to start with the world record velocity versus race time. Very intuitive graph from 1925. As you increase the race time, you decrease how fast they're running. Very intuitive, not too hard to understand. If we change it for different types of sports, men's, women's, swimming, running, you can see that there's somewhat of an asymptote. You can only go so fast in so little of a time. Now, we can start to discuss that based on this concept that we've already discussed called VO2 max. Now, does anyone have any recollections of what VO2 max is? We've talked about it a lot. Maximum oxygen uptake, right? So performance velocity or power is a complex equation based on a lot of concepts we've already discussed because this is an end product for exercise physiology, right? Two of the main two of the main adaptations for ventilatory and cardiovascular training is capillary density, mitochondrial density. Now, they're the most important, or they're the most prevalent, however, not the most important necessarily for this equation of power or performance, right? So now we can talk about does VO2 max contribute to performance? And from a great study from 1976, you can see that on average, as you increase VO2 max, you have increased performance in the scope of a decrease of running time. Now, however, this isn't end all be all. As you can see, some VO2 maxes are higher with worse or slower times. So it's not just one to one. It's a complex equation, a complex system, right? Even more so, they look at distance specifically on this. And even though we have outliers, you can see that as you increase your VO2 max, you are going faster in your overall area of performance. And it's not just slow, relatively, 1 mile or longer, 6 months, right? It's not just time dependent, it's performance dependent. Now, there are certain things that go into VO2 max, and we've already talked about them loosely, convective and diffusive, right? Now, can anyone break down what these would be? Why they are essentially condensed into these two things? You need oxygen, so it's how it gets from the air to your blood through the lungs, and then how it gets from your blood to your muscles. Those are the two things. There are seem to be pulmonary limitations because even if you increase the oxygen percentage, you get a relative increase. Doesn't matter if you're normal or highly trained for what your VO2 max is. So there's only so much that your lungs can do. Same thing with cardiac output as well. There is an oxygen carrying capacity. So even though there are factors that go into it, again, it is complex. Same thing with capillary densities, right? The more capillaries, more fiber ratios you have, the larger your maximum oxygen uptake. We already know this, however. Same thing with mitochondria, right? As you increase mitochondria, increase VO2 max, better performance, better times. And it's not just for cardiovascular exercises. You have the same result, the same trend in resistance training, single leg exercise. So now we come back to this old equation that we originally saw about power, performance, output. And we can see that there are a lot of components that go into it. We've talked about our VO2 max, maximum oxygen consumption. But we need to talk about lactate levels. And this has come into place earlier on in where? Metabolism, correct. Within glycolysis, the first step, because we have lactic acid as a byproduct. And as we can see, as you do more intense short-term distances, you have a higher lactic acid production, right? And the interesting thing is as you increase your capillary density, you actually decrease your lactic acid threshold, or your LT, because you can actually flush the lactic acid out. Now, as you increase your lactic acid threshold, you increase your performance as well, because you're hitting a fatigue point from the lactic acid at a later point in your training, in your performance, right? So you have all of these concepts coming into play, not just your oxygen uptake, but your oxygen uptake at that lactic acid threshold. And this is where, for example, running economy comes into place. Now, running economy has a ton of factors. Same thing with VO2 max, right? This is why this is the end of exercise physiology, because now we can talk about all of these concepts in more detail. Because now you have how you train, what you train, different types of adaptations, different types of muscle firings, neutron firings, different types of cardiovascular adaptations, mitochondrial density, capillary density, and then you can talk about more specifics, right? Biomechanics, flexibility, body comp. You could talk about metabolic factors, lactic threshold, physiologies, different types of environments, heat, altitudes, which are going to change how much oxygen is there, and the partial pressures that we've talked about, correct? So as you increase your economy, you're going to increase your performance lower than your maximum output, right? As you can see in both of the figures shown. You're still going to hit your maximum threshold, but at a similar rate of performance, you're going to have a lower VO2 max the better trained you are, the better your performance is, right? So now we come back to this graph and we can look at it more in depth and actually discuss it more in depth on what it means for the data points to be where they are. And it ultimately ends with critical power. This is the crux, essentially, of exercise output, is critical power, which is a point that you can keep going with fatigue. And it's predicated on lactic acid threshold, VO2 max, which we've already talked about, right? It's an important parameter of aerobic function. That is the premise of critical power. Now, it is not the same thing as lactic threshold, as you can see, right? You have your lactic threshold relating to a perceived amount of work. They are not the same thing, even as you train, because you can have an increased lactic threshold, but it's not actually affecting your critical power, interestingly enough, right? It's a two-parameter concept, right? It's the max amount of work that you can do above your critical threshold, that it's essentially how much, like, your work rate, your work capacity. And the interesting thing about critical power is that you only can do so much work above your critical power point. It's finite based on your body, on your composition, off how your body handles lactic acid, fatigue, how it generates energy, so ATP, which we've talked about in electron transport chain, citric acid cycle, glycolysis, creatine phosphate. It's a very, very complex system, right? But we can see that if you increase past your critical power, the amount of fatigue you have, the amount of performance that you are exerting drops off significantly, as you can see in these graphs. You increase your CP only slightly, your VO2 max hits, right? Even though you could keep going off of a longer time. Your blood lactate, even though it equals out on your CP, if you increase past that, way past that threshold, right? So there's a few factors that determine critical power, and they mainly have to do with um, how your body handles getting rid of fatigue, getting rid of that lactic acid, right? That's why we have this study that had occlusion, which is when you um, are restricting the blood flow. If the fatigue cannot leave the area, you're going to have a decrease in your critical power, right? And it pretty much determines a range of performances that you can think of, right? And this is the crux of exercise physiology, right? And why I needed to have everything else before this. Because this impacts, it doesn't matter what you're doing. You could be a lifter, you could be a runner, you could be a fighter, right? You could be a novice, you could be an expert, you could be training someone, you could just care about yourself. You could be a novice marathoner just trying to run, right? And you can better determine how you want to train, better determine where you're at, where you want to be, what factors that you can do to actually train, what to focus on, et cetera, and et cetera.